Alright, in this demonstration we are going to be using beans to help us understand where the concept of relative mass comes from. So the masses on the periodic table are actually relative to the mass of carbon-12. And so we said the AMU, the atomic mass unit, is a relative mass unit. So we're going to be looking at where that, what a relative mass means, and also where the mole concept comes from. It's our way of counting particles without actually counting them, and we're going to be counting them by measuring mass. So I'm going to be filling in your data table as we go. I'm going to put the weighboat on and tare it so that the mass we see on the balance is the mass of the beans. And I've got 100 of each bean type. And so we're going to start out just like on our data table. We'll start with the white. So I've got 100 white beans. I'm assuming the mass of the 100 white beans. And that is 19.2 grams. So you're going to write that down. 19.2. Put those back. Make sure the balance goes back to 0 with the weighboat on, and then we'll do black. That's 19.9 for the black. Next in line, we've got the lentils. That is 4.8. These are all in grams. And then lastly, we've got the brown beans. 41.6 grams. Okay, so the next step is to find the relative masses. The directions say to choose the the smallest bean. So clearly if you look at the masses, the lentils have the smallest mass for the 100 beans. So that's going to be what everything else is relative to. So I'm going to divide all my numbers by the relative mass, by the lentil mass. And so 19.2 divided by 4.8, and that gives me 4.0. So if you go down the line and divide each of the numbers that you just wrote down by 4.8, which is the lentil mass, and I will do the same. Notice the lentil divided by itself is 1, and we're measuring all our masses to 1 decimal place, so that's the way we should record our relative masses, to 1 decimal place. Okay, so I have 4.0 for the white, I have 4.1 for the black, I have 1.0 for the lentil, and 8.7 for the brown. So those are all my relative masses. So the next step is to count out the number of beans in that relative mass. Well, relative mass technically doesn't have any units because we had gram divided by gram. The gram units cancel out. But since our balance is in terms of gram, we're going to measure out how many beans does it take, I'm starting with white beans, how many white beans does it take to get to the mass of 4 grams? And that's our relative mass. So let's check it out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. All right, 22 beans. So we'll write that down for number of beans and relative mass. And we'll do the same thing with the black beans. So we're looking for 4.1 grams for the black. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. All right. Let's see. If I take away one of these, 20, put one back, 4.1. Okay, so 21 beans in that relative mass for the black. Lentils, let's try that out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Okay, so 22 lentils getting me that relative mass of 1 gram, and then we'll lastly do that for the brown. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, looking for 8.7, 22, and probably if we take one away, yeah, we're closer with this to 8.7. Okay, so that was 22 beans for the bread. Okay. So now our data is collected, and now we can answer the rest of the questions.